about briefly about introduction to the MPLS, because somebody else will talk in depth. I don't want to enter into his area. And also I will talk to the VPNs and how the MPLS VPN networks have been. Yesterday, Mr. Anandam was asking about how it is planned, where it is deployed, how it is deployed. I will touch upon to some extent on that. And I will also talk on the user cases where we have implemented this across the globe and across in RailTel also, where we have deployed for other customers also. And we will see what is the costing, tariff, commercial aspects of that. Okay, yeah. Please reserve your questions. We can answer at 10:50 as Ali sir has told that we will take the questions at 10:50 again. Yeah. The VLAN, we have seen about LAN, we have saw about WAN, and we will be talking about the creation of virtual local area network. Physically, it will not be. It will be as good. It's only for virtual. Tell us the challenges today with the LANs. LANs normally we are creating where we have the users. We are bounding that physical geography is binding there. All the subnets of the LAN users are pumped to the hubs or the bridges or the switches. Users we are grouping in the LAN of the location wise. No security on the segment. Addressing is constrained. Router ports, as yesterday also we discussed, router ports are quite expensive. We can't load the router ports with just for broadcasting. These are the challenges. To address that, we have come out with the VLAN option. VLAN is a logical group of network devices that appears to be in the same LAN. It is appears. It is not in that. Physically, it is not present. It is a virtual creation. Take the similar scenario of the scenario. Your SNT team, all SNT team of your division or your zone wants to have to communicate within only the SNT teams. Why you will be loading entire to your zonal network? So you create a virtual LAN. All this virtual LAN will be communicated, broadcasted within this WAN ID, VLAN ID created for your SNT. So the SNT officers may be at Guntakal division, maybe at Vijayawada division, maybe at Nanded division, maybe at Guntur division, but physically you are at apart, but logically you are into the same LAN. So distance immaterial there. So there that is called VLAN creation. So every network group department will be given one VLAN ID. So whatever you broadcast, it will be circulated to the only the VLAN, the users of SNT only. In normal LAN, what happens is any user broadcast, it goes to the entire LAN users, loading onto the broadcast with that switch or the router or the hub where it is connected. So that type of the problems will be addressed by using these virtual LANs. These virtual LANs are configured as if they are attached to the same physical connection, though they are differently. VLANs can logically segment users into different subnets. Example of this. If you can see this is a traditional LAN where you have a LAN, one floor, first floor, second floor, third floor LAN. So every floor you have a shared hub. Through hub, it will be connected. But suppose some of the, you can't connect vertically like this. You can connect only horizontally because it is. Whereas if you use this VLAN, one of the department of SNT sits in first floor, one officer sits in third floor, other officer sit in ground floor. You can able to connect through VLAN, but that is not possible with traditional LAN. There is the advantage of having this VLAN today. If not only sitting in the same building of different floor, it sits in different across the globe, you can able to configure VLAN and you can able to ensure virtual connectivity as if he is in the LAN. This reduces the broadcasts which can be circulated within the VLAN number only. Suppose whatever originates from S&T department, the VLAN ID created was 1. It won't go to that broadcast to the VLAN 2, which we assign to the engineering department or to the finance or accounts department. So that will goes to within that VLAN, the broadcast numbers will be unnecessarily not loading that. By using this switch, this can be done by using the VLAN switches across that location. Suppose you want 10 officers at Singhdava division, 10 officers at Guntakal division, or all to be. So you put a switch there and create a VLANs. It will pass through these switches and get hooked to your router. So this is the advantage of doing this. So it is a typical example. Catalyst switch of Cisco, engineering, marketing department, accounting department. They are all altogether physically not in the floor. They are into different floors, but created the similar as if they are in the same floor and LAN. The VLANs. They are statical, dynamical. Statically, configuration dynamically. This is the job of the network administrator. Here port means it is not the application port. It is the port of the switch where you are connecting. Let us not get confused here. The port is not the application port like yesterday, what we spoke about the FTP port or the NAS port or the DNS port or the traceroute port. This is the port of the switch or the hub where you have created. Basically, this all happens in a switch, not in a hub or this thing, because it should be a manageable switch. It is a configurable switch. Switch only you can configure. You can't configure the hub. You can't configure the bridge. So this happens in a switch. So the network administrator will configure the port by port a different VLANs. Default for any switch is a VLAN 1 will be created. Suppose you want to create the other VLANs, you have to configure it. We will see how it does. Network administrator is responsible for keying and mapping these ports and VLANs. Each port is associated with specific VLAN for a static. Coming to the dynamically, ports are dynamically worked out VLAN configuration, no manual configurations. Uses the software, that is NMS, network management software, to map the MAC addresses to the VLAN mapping. How it maps? It maps of the existing host MAC addresses. Again, this is job of network administrator. You see the static VLAN switch port. It's a 10 base T switch. It has got different ports on the switch. Default ports VLAN 1. Unless until you configure that, it will go to the VLAN 1. Static membership VLANs are called port-based, port-centric membership VLANs. This is the most common method assigning ports to the VLANs. As a device entered into the network, it automatically assumes that VLAN membership of the port which is attached. Suppose the port 11 or 12, you are connected to the VLAN 1. It is connected on your network as a VLAN 1. Suppose you configure the port 1 here as a VLAN 12, it connected to the VLAN 12. There is a default VLAN on a Cisco switches, that is a VLAN 1. Dynamic VLANs. Dynamic membership of the VLANs are created through network management software, as we just now discussed. Dynamic VLANs allow the membership based on the MAC addresses of the host connected to the switch port. As device entered into the network, it queries the database with the switch asking for VLAN membership. All this to happen, you need to have a server. Who does this? A server does that. So you need to have a VLAN configuration server which is there onto your network. So this maps creates the VLAN basing on your MAC addresses of individual users. It questions what is. So the MAC addresses will be provided by the server. The MAC addresses are checked with the database of this server. There are access ports. What is the trunk and what is access port? If only one single device is connected to the port of the switch, then it is called an access port. multiple devices. You can connect multiple hubs. Hubs are not switches, which are not manageable. Another switch is connected to the same interface, creating the same VLAN. Then it can pass, no problem. But other VLAN of the same switch cannot be in the access port. It will be other in the trunk port. Another switch is connected to this interface. The link is carrying the multiple VLANs. Then this is called the trunk ports. That means trunk port carries many VLANs. See this access port, VLAN 1, it's only VLAN 1, VLAN 2, VLAN 2. But whereas trunk port combines the VLAN 1 and VLAN 2, carries on the single link. What is the advantage of this? This doing the trunking port, you can save the switch ports. You don't need to spend, otherwise in access ports, you keep on using the switch ports. But here, you can optimize the switch port utilization by trunking in creation of the VLAN IDs. VLAN trunking. This is the backbone carrying the trunking of all VLANs, VLAN 1, 2, 3. These are the VLANs in one, through one switch, other VLANs. In a switched network, trunk port point-to-point links supports the VLANs. The purpose of the trunk is to conserve the ports. Just now we spoke, to save the ports between the two devices. We'll implement VLAN trunking. There are two common methodologies that is being used called taggings for trunking purpose. One is ISL, inter-switch linking, that is trunking, nothing but trunk tagging. Other is IEEE standard 802.1q. Both are used for tagging of the VLAN on trunks. Now this ISL, inter-switch link. There are the two switches here. Each switch is carrying two different VLANs and trunking through this ISL, inter-switch link. An Ethernet frame is encapsulated with header that transports VLAN IDs of 1 and 2. The ISL encapsulation is added to the switch before sending across the trunk. It is like yesterday we have seen frame along which we add the frame header. So at the receiving end, frame header will be removed, only frame will be received. Similar way here also. And you see in the ISL, there is a 4 bytes of CRC, cyclic redundancy checks for error corrections. This is the total frame of ISL header of 26 bytes, encapsulated Ethernet frame, and 4 bytes CRC, cyclic redundancy check. The switch removes ISL encapsulation before sending into the non-trunk. That means this is required while you are using a trunk. When it comes to normal switch, it doesn't require, it will act like a access port there. In IEEE, most widely used IEEE 802.1.q trunking, significantly less overloaded than ISL. It inserts only 4 bytes into the Ethernet frame. These Ethernet frames are, if you can see this, in the ISL, 4 byte cyclic redundancy checks is added to the each frame. But these frames, these cyclic redundancy checks are all the time different than what we used to use for Ethernet frames. In Ethernet frames also we use CRC. These are all addition to what we used to use for Ethernet for ISL link trunking only. This is 802. Again, source address, destination address. Tagging, length, data, and this is way how this look like. Trunking protocols developed effectively to manage the transfer of the frame over different VLANs on a single physical link. Trunking protocols established agreement for distribution of the frames to the associated ports at both ends of the trunk. What are the benefits of the VLANs? Reduced administrative costs so that we can by saving the ports of switches. Efficient bandwidth utilization, better control of the broadcasts. The broadcasts are the big challenges in a network. You see, when we talk about the security here, the data meant for department of stores cannot be going through the S&T department here because that is on different VLAN. So there is some sort of the security is being obtained by creation of the VLANs. The data meant for particular department only pass through particular VLAN. And it distributes the traffic load. Instead of all these loads goes through a single switch port, it will different ports of the VLAN ports of the switch. Yeah. So before we go to the basic understandings of the MPLS VPN, I will be probably this topic will be initially be repeated by some of my colleagues, which will start at the basics. But just I want to talk about this to make you to understand what VPN is, then what MPLS VPN will be. Then we will be seeing how this will be used for our user cases and all.